we have a quorum. This is great. Welcome everybody. I'm super excited to bring down to Carmen today a gentleman and a scholar, Leonard Paul. Has been doing really incredible stuff with game audio, and composition, sound design, and kind of breaking away from the norm of game audio development, which is kind of something that's always excited me about his work, and we have a lot of similar interests. And so I'm really happy to have been able to bring Leonard down here. Leonard runs his own game audio school, school.videogameaudio.com. He has taught in universities. He is a wonderful educator and works in industry, and is currently the composer for an upcoming very cool documentary on game sound called Beep, I believe. Yeah, Beep, right? Which is successfully kickstarted and is under production right now, and it's going to be very, very cool. So Leonard's in town, and kind of in conjunction with, you can leave that open, Dave. That's okay. And Chet is trying to watch. In conjunction with the Game Developer Conference, which is running right now. So we're very happy to invite Leonard down here. So with no more ramblings from me, Leonard Paul. Well, thanks.
All right. Well, yeah, thanks, Rob. I guess that's a great introduction. What else to add to it? I've heard about Carmen for a long time. I did electroacoustics up at Simon Fraser University in Canada, so I'm based in Vancouver, Canada. And so it's a surreal experience for me to finally come here. And oddly enough, for my first time here to get to talk. So yeah, thanks a bunch, it's awesome. So yeah, I think that the nature of this talk would be kind of free form. Probably what I'll do is make it so that we go to an hour, and then for people that have all sorts of stuff to do, then you can like break and do that. But then for those that want to hang out a bit, you can just ask questions, and then we can sort of work things that way. So it'll be more sort of free form at that point. So yeah. And if you do the Twitter thing, I'm in video game audio. And so here's a bit of my history. So like I was saying, back in '91, I started doing electroacoustics at SFU. So that was with, well, a few different people. There was Barry Truax, who's sort of well known for granular synthesis and granulation. And Martin Gottfried, Arnie Eigenfeld were other professors there. And yeah, I was basically doing sort of music with a buddy of mine, because I grew up in a small town on a farm in Canada. And so the idea of trying to fill up the time was done with using like an old Fostex 4-track, and I had like a Commodore Amiga, so it was like, 4-channel, PCM. Before that, I had a Commodore 64. So yeah, I've basically been doing like computer and like digital audio for a long time, and I'm still doing it. So obviously, I still like it. And as far as like my experience in the industry, I started in '94 working on this game here. So that was Electronic Arts, and the way that I sort of started there was that I was doing programming at SFU. So I did sort of a double degree. I ended up graduating with an honors in comp sci and then an extended music minor, which basically means sort of programming plus music stuff. And but my start, because I was like, I really want to do like games for programming. So I ended up doing a co-op, and when I started there, I was doing like testing. So quality assurance, it's actually quite hard. So I did that for the first 4 months, and I was supposed to be there for 8 months because of a bureaucratic kind of issue. I actually technically got not fired, but my contract was ended. So then I had to get another job, and then that job was programming, which was really cool. So for NBA Live 95, what I did on the Sega version of that is that I programmed what's called an Easter egg. People know what an Easter egg is? Okay, all right. So it's this little section in the game that's sort of hidden. And so if you type in reflog, or if you go all the way through, like the entire season, and then you lose the finals, then you go onto this golf screen. And so that I took the graphics and the sound from another, like their golf game, and then I integrated it into that system. So then basically you just get to shoot like a hole of golf in the basketball game. So that was fun. So I actually started out more so on graphics. So I was doing like assembly language coding because that was the way to get things to happen quickly on the Sega. One of the cool things that EA did that was kind of top secret at the time is that the Sega or the Mega Drive, it would allow you to do one channel of sampled sound, and you have to remember like the chips back in those days were super slow. So what they did to get 2 channels of digital audio is that they did software mixing. So to get that to run while a game was running was pretty amazing. So that was sort of whatever, a function that we're able to use at Electronic Arts. And there's all sorts of other stuff that that EA has done in the past where I go to the Game Developer Conference. I did my first talk there in 2003, and there's things that people are like, hey, nobody's ever done this before. And it's like, actually, we did that, but you can't talk about it because whatever, it's proprietary information. So if you've ever worked with the industry, you kind of know what it's like when you're like, ooh, I could just. Okay. So, yes, I can talk about it now though because it's not going to help them in their market share, right? So, yeah, in 2001 I started teaching game audio. That was at a basically like a private school. So it was people that had graduated high school and wanted to learn more about game audio and that kind of stuff. And what I did then is that this is what are we 2015 now? So this is like 15 years ago. Weird. So back then, when I first started teaching, is that there weren't middleware systems. So nowadays, there's a system called Wise. There's another one called Fmod Studio. And then there's other ones, too, that are kind of built into Unity and Unreal and other game engines as well. So the idea with middleware is it just allows you to put your audio content into the game in an easier fashion. Back in those days, that didn't exist. So I actually programmed my own game audio engine in Pure Data. So yeah, I was using it back then, and I'm still using it now. So I really do like working with PD. I find that it's really fast. I still program in C++ from time to time, but there's some other stuff that will come back sort of full circle here about some cool things that are happening now in with PD. 2002, I did audio coding for Need for Speed Hot Pursuit 2. So basically, the PlayStation 2 is an interesting beast in that it was basically like 2 PlayStation 1s kind of stuck together. In fact, that was like literally the way that it was for the audio processor. So the SPU2 was like, instead of having 24 channels of audio, 80 PCM, well, they called it BAG for whatever reason, it was 48 channels. And they had a special function that would allow you to do ring modulation. You had access to reverb, delay, and that was about it. But the actual audio processing was done on the PlayStation 1 chip. So they relabeled that to call it the input-output processor. But the funny thing about that one is that that was the way that they made the PlayStation 2 100% backwards compatible with the PlayStation 1. So they actually had like the chip in there. So it is totally hardware compatible with the PlayStation 1. So they were like, hey, what's the this weak chip? What are we going to use it for? Oh, audio. Oh, and to the game controller. Oh, and to talk to the the CD/DVD drive. So when I was programming at, well, it was called Black Box, but they got bought up by Electronic Arts. When I was programming there, I was able to get the audio driver to basically run from peak utilization, where we were peaking up to like 160 milliseconds. And if we're trying to run at sort of 60 frames per second, then you want to basically try and get all your audio processing so that it fits into sort of like about 16 milliseconds or so or less. And so I was basically able to crunch it down to a tenth of what it was. So when you're doing audio coding, as most of you know, it's not just the fact that you have this sort of average, like you have to make sure that the buffer's filled in general. It's like if you have one thing that's a blocking function, then you're going to run into problems because it'll break the audio stream, right? So that was one of the things that I sort of fixed there. So just saying that, you know, I've done like sort of real audio coding in the past, and there was even another game before this called, that I didn't put on here, that was at Modern Groove Entertainment. It was a .bomb company, so it totally blew up, and it was just, yeah, it never sort of, we were able to ship the game. So anyways, Modern Groove, the company, and then what we did is we collaborated with the Ministry of Sound in London. We got 5 hours of DJ sets, and then we used this new, you know, game system called the PlayStation 2. It wasn't even really out at that point. We got some of the early dev kits, and they were so early that they were buggy, and the environment that we were working in, because it was a .com, was like open concept, you know, whatever. We're all programming, and I don't know, whatever everybody else was doing, but I was programming. And it was a dusty environment, and what happened is that the drive, like the intake, would actually get clogged, and they would overheat, and because I was the only one streaming stuff off the drive, then it looked like my audio code wasn't working. But it would fail so erratically because it was actually based, because it was like stuck full of dust. And then the great thing was is that you crack one of those systems open, you open it up, and they actually had like a solid, like, it was like a gold-plated sheath that went around the whole unit on the inside, so you couldn't actually touch it at all. You had to ship the unit back to Sony. Anyways, a little bit of a side thing there. And also the thing that was really great at working, like that was in 2000, that they hadn't even translated the manuals to English. So there's all this like Unicode kind of, like, you couldn't even read it in Japanese. It was a big mess. It was the PlayStation 2 was like, the development system was Linux. So you can imagine like working on Emacs or VI or whatever. I mean, we used better editors than that, but still, it was exciting times. So, moving on. Okay. 2003, I gave my first talk at GDC, and with that I was sort of describing the relationship and the balance where game audio has with the creative side and then with the technical side. So I was sort of balancing out the idea of like, if you want to get anything done, like in an interactive audio way, you're going to have to do some, you know, creative stuff and then technical stuff. And like myself, I can do both, but like within a gaming environment, often you'll have to try and figure out how to divvy up the work between different people, because you just don't have enough hours in the day, right? And sometimes you have to go with your strengths. So you're like, okay, I can do, you know, whatever music better, and then I can get help from the coding on this side. So that's what that talk was about. It's just talking about how a lot of the times things fall in the middle because you don't necessarily have a shared vocabulary, where you've got like really creative types and they're just like, I don't know, just make it happen. And you're on the other side going like, well, you know, coding is creative as well, and I could do what you want in like all these different ways, but it'll come out feeling different. I'm not sure if that supports your vision or not. So yeah, that's what that talk was about. So that was fun. And GDC, of course, is going on right now, but I'm not presenting there. I'm presenting here. So maybe next year. So this one, I got into talking about granulation, which is sort of related to when I started back at Simon Fraser. So I sort of, one of my like things is working with granulation in games. And the reason why I really like that is that when granulating sampled sound is that you can change the sound and make it so that it fits the picture as it's changing within a video game. So if you're, you know, your tires for the car are squealing around the corner, depending on how fast you go, how hard you go, or all that kind of stuff, you know, revving the engine, then you'll get different sounds, and using granulation is a great way of simulating that, because it's from real world sounds. Right? You can definitely like use mathematical models to model an entire car engine, but I think that with granulation that you can get a lot of sort of win, you know, with not too much effort. All right, and then skipping ahead here, this is what I've sort of done more recently. So Retro City Rampage, has anybody heard of that game? A few people? Yeah? Okay, so Retro City Rampage is this game here. It's basically like Grand Theft Auto, but like for the Nintendo, but it never existed kind of thing. So it's sort of this nostalgic throwback. And the cool thing with that one is that, you know, these days I'm not working so much in the technical context, but with this one, well, the composers and I, there's 2 other composers, I did all the sound design. What we did is that we modeled all of the sounds using the original Famicom or NES specs. So there's 2 pulse waves, there's a triangle wave, then there's a noise channel, and then there's a really crappy sampled sound channel. So for all of the sounds, all the sound design, all the music, it uses that constraint. We didn't limit ourselves to like the number of voices, but we definitely wanted to have the feel like of that kind of, you know, like the same thing with the graphics is that, you know, there's all these sprites and stuff moving around, and if you did it on the actual NES, which Brian has done, he actually did start out doing a real NES one, is that you'll get sprite flickering and all this stuff where nostalgically, like that kind of stuff isn't so fun. Like you're like, yeah, it's played for it's not fun. Like you're just looking at the screen, it's like jarring. So it's sort of like you just want to emphasize the things that were nice and sort of play down the things that were not so nice that you remember back in the day. Because like that's the thing. It's like if which I did is that if you go back and play like the NES, there's a lot of crappy games. So why would you bring that back? You want to bring back all the good stuff. So that's what that game's about. Vessel, that one is it's an independent game, and it's a 2-dimensional puzzle platformer, and it uses a lot of like liquid physics. So you are this character that sort of can sort of shoot this watery type stuff, and then you solve puzzles and things like that. And the audio was quite tricky to do with that. So what I did to sort of get over those issues of getting it in sync is that I used granulation. So I cut all my water stuff up into little bits, and then we used kind of a tricky system to get all that stuff to play back properly. So, and then we also, I also did the adaptive music design for this. We used the music of John Hopkins. He's an electronic artist from the UK. So his stuff is really cool. And then, yeah, here, 2012, I launched the School of Video Game Audio. So that's, I just teach game audio online to various students from around the globe. And yeah, it's still around, so it must be doing something right. And people are enjoying themselves. And yeah, people are also slowly getting hired, because I mean, like, it's a very competitive industry. So I do what I can to really help people out. And that's why I'm doing this talk, obviously, is to try and, you know, have a conversation and make it so that you can ask me stuff specifically about your own experiences too. So we'll get to that kind of later on. And then what I'll focus a lot of this talk on is the game SimCell, in which I used pure data to develop all of the sounds for the music and the sound design. The only thing that doesn't use pure data is dialogue, which I recorded with my friend. So yeah, we'll look at that here. So with SimCell, it's a game for high school students about learning about the human cell and plant cells. It's published by Amplify. And then the game company that I was working for is Strange Loop Games, and they're based kind of in Seattle, but then there's also some people that are working from Australia as well. So, and then I was based in Vancouver in Canada. So we would do sort of like Skype meetings every couple of days just to stay on track. And the game audio coder, Kieran, awesome coder, he was based in Australia, so time difference was always interesting for us to try and figure out how to collaborate. I'd put something in, or he'd need something, and it's kind of like, oh, I'm waking up, oh, I'm going to bed, or oh, I had some coffee, or oh, I didn't sleep last night, or, you know, it's just like, all right. So we were able to get things happening, and now Kieran also worked on Vessel with me as well, which was great. But with this game, SimCell, it was just it's an educational game, so there was a smaller budget, smaller time scale, so, you know, there's just things that sort of fell by the wayside. So what we did with SimCell is that we integrated libpd. libpd. Anybody using libpd? Somebody? Anybody? Yeah? Yeah, thinking about it? Okay, all right. So anyways, libpd, I'll go into more details of that later. So we prototyped with Unity 3D. And if you want to see a presentation of how the audio was done, there's the link is on the little one there. It's basically Keir had done a presentation at the Nordic Games conference, and so he has like this 70-page presentation about that. But unfortunately, we didn't use it in the final game due to performance. And if you've ever worked with Android, like this was a couple of years ago. It was a couple of years ago, and the latency was absurd. It was just, and it was really almost impossible to get over. So it was like I think we had over half-second latency. So when you're working with a tablet game, it doesn't make sense. Like you've got, especially high school students, if you have a half-second, they're going to destroy the tablet because it's frustrating. It's unnatural to press and hear, right? So we couldn't quite get around that. And then the thing is that they also published SimCell 2, in which they changed the platform to iPad, but then they didn't have enough budget for me to actually put the stuff in there. So I was like, foiled again. So if you want to play with some of the demo patches, you can download them here. So this is just on the sound design part, and I am going to make some of the music stuff public as well. So I have a whole bunch of patches, but I made 10 of the sort of the better ones available on my website there. So I'll kind of has everybody used Pure Data here? Not, no? Almost? Okay. I'm gonna just screen through it, just to make sure we're all on the same page here. So it's a visual-based scripting language. It's similar to Max MSP and Reactor, if you've used those. You can interactively edit your patches, and it's been around for a long time, and it's very robust. I've used it I do sort of installation art from time to time, and there was an art piece that I had running near Vancouver that was running for, I think, maybe even like 7 years using Pure Data. So it is sort of like, I believe, industry grade. If you get it working, it's kind of like Linux. It's kind of like, okay, don't touch it. So it's, I really love using it, because the thing is that I can do a presentation like this, and then people like yourselves can just try it out. I don't have to say like, oh, well, then there's like the demo, and then there's, you got 90 days or whatever. It's like, PD is free and open and all that kind of stuff. So I think it's good for audio people to learn and try it out. The cool thing is very cross-platform, so it runs it's basically been developed on Linux, but it runs very well on Mac as well, pretty good on PC. And then you can run it on the Raspberry Pi and other systems as well. So it's pretty cool that way, free and open source. So good stuff there. So the advantages are that it's free. There's lots of PD patches available from this guy, Martin Brinkmans, who I used a lot of his patches for my music project that I'll show you later. RJDJ, this is sort of a company out of the UK where they standardized a whole bunch of PD patches and put them together, and then you can make your own sort of stuff for phones. So anyways. You can download all of their patches that they've sort of tidied up, so it's almost like a little library, which is nice. And so it's quick to prototype, like I was saying, it's interactive. If you want to create your own objects, you can do that in C and make the performance go up, or if there's an object that's missing, you can just program that away and do it yourself. So libpd specifically is available for iOS and Android, and you get good support from the community. But unfortunately, the major thing for me was that it had poor performance because it's an interpretive language. So it's constantly reevaluating the scene graph, which is fine, but it does, that's cool if you're changing the patch, but if you're not changing the patch, it's kind of wasted effort. So there's a way to get around this, and I'll speak about that pretty soon. So and I want to have it on different platforms. So if I'm working in games, I want to have it running on the PlayStation 4, whatever, all that kind of stuff. It would be nice to have that available too. And what I found is that because libpd is what's called, it supports vanilla PD, which is kind of like this small original subset that's put together by Miller Puckett out of, University of, what is it?
San Diego.
It is San Diego, yeah. So he's down there, and he produces his own what's called vanilla PD, and then people do extended PD on top of that, which is sort of like all these extra functions that allow for a whole bunch of, like graphics and all this cool stuff. But then there's also like licensing issues with some of those things, and so libpd just supports a little small chunk. So sometimes if you use patches that are using extended PD, then you need to figure out how to reprogram them so that they work with just vanilla PD. Yeah, visual spaghetti is common. Like I'll show you some of my patches. They're nice and messy. I'm a very messy person. That's just the way that I am. And yeah, there's no tech support because it's open source, and it's still an emerging kind of like bleeding edge in certain ways. So sometimes when you try to compile stuff, it's like, oh yeah, that doesn't work, and then you have to talk to people who are like, oh yeah, I totally wanted to, yeah. Anyways, it's sort of when you're working with games, it's just tricky. You got to figure out how you can get it to actually work. And so with SimCell, it got to the point I was even trying to like optimize using single instruction, multiple data kind of compilation stuff to try and speed it up. I reduced the sample rate, I reduced the number of channels, and I was able to get it down to about like 20% of the processor. And that was totally like irrespective of like the delay issue that we were having with the latency. And so 20% was just too high, because usually with games you get about 10%, the rule of thumb is 10% of CPU and then 10% of memory, and then often between 5 to 10% of total budget. So 20% on CPU is just too much. So here's what could really change things with pure data. It is heavy. So it's basically two guys, Martin and Joe. They happen to be in town for GDC, and they were in London, so I talked to them a lot when I was there for the AES for Games, which was like, it was about 3 weeks ago or something like that. And so what they're doing is they're doing a PD to C compiler. So they showed this off in October of last year for the Procedural Audio Now meetup. And so the thing that I'm most interested in is that it will compile a PD patch into a Wise plugin. So Wise is, the middleware that I was talking about. It's quite popular, made in Canada, so made out of Montreal. But the other thing that's really cool that's happening right now is that they're actually focusing on compiling PD to web audio. So they're getting it, yeah. Have you been looking at it?
No, I'm just super interested in web audio.
Yeah. Yeah. Yeah, no, it's cool. So yeah, there was sort of like a little bit of work that was done before, where there's a guy that was taking like PD patches and then like basically doing a translation from the scene graph into JavaScript, which could be used for web audio stuff. But then there was so few objects that were supported, it was really not helpful. Whereas these guys, I think they're going to do it. So, cross fingers. I mean, I saw them talking to the Wise guys, and the thing is that Wise is well funded. So they have a lot of people working for them. And so if they're able to basically tell, Audio Kinetic, the people that produce Wise, it's like, okay, well, if you want to have any type of plugin for, that is made out of PD, then we can compile it for you, and then we'll just take a licensing cost off of that. So this is one of the sort of practical aspects of game audio, and as you know, audio in general, is that it's one thing to have an idea, but it's another thing to have enough money and time to get that idea realized. So yeah, hopefully, I hope that Heavy makes it. I think they're really good coders, though, and they're really accessible. So this is called real-time parameter control. It just means that you're getting parameters from the game. So say if you're driving a car around a track in the game, then it might just be the RPM value, or the velocity of the car, or like sort of I don't know, all sorts of different things that you can drive from the physics engine, sometimes from the graphics engine, sometimes from the artificial intelligence. So you're getting all this stuff from the game, and then you're using that sort of like continuous controllers, like in the MIDI sort of idea, and then you're using that to drive the audio for the game. So that's what Heavy can do, is that it just does that thing really easily, because these parameters are already exposed like in your game if you're using Wise, and then to be able to drive your PD patch, you could do like generative music stuff, you could do complicated granulation stuff, which those are two things I'm very interested in doing. So, or you could maybe do even like Well, I mean, you could. I guess you could do physical modeling as well. I'm not sure if physical modeling would be the best thing to do with PD. You'd probably want to do that in C to begin with, but you might be able to do that. And the other thing that's neat about pure data is that, and this is sort of a whole side thing that I know you've talked about, Rob, is that on one side of the, you've got the game and it's spitting out, like say, all these, for all the objects in the game, continuous X, Y, Z sort of values, things moving around, how fast they are, maybe, even acceleration as well. And then you got to figure out a way to translate those parameters into something that makes sense, that has meaning. So that whole extra layer there is something that, if you don't have a good game audio coder, this is sort of talking about what I was trying to get at in 2003, is that a lot of the times you'll just drive your synthesis or your game audio engine directly, which is in general a mistake. So when I was working on Need for Speed, one of a real obvious thing is that you would say oh, okay, we'll sample, record a car, and then we'll make a loop out of that sound, and then, well, because we don't have a lot of processing, what we're going to do is just basically tie the velocity of the car to the playback rate of that sample loop, right? Okay, well, that might seem like it kind of works sometimes, but the problem there is that if the physics folks do kind of weird things, you will definitely not get the nice sort of even if you tied it to RPM, you might find that the physics RPM, it does weird things and it doesn't actually sound good. So the physics people are doing things that work well on the physics side. They're not going to do stuff necessarily that makes your stuff sound good. So it's good to have an abstraction layer in between there. So another sort of metaphor is kind of you've got your audio engine, which is like a guitar, it's like an instrument, and then you've got the game, which is the robot that's playing the instrument. But the thing is that if you don't tell the robot folks what the way that you're changing your instrument, then the first note that robot might try and play would go right through the body of the instrument. You have to really continuously adjust things. And it's not just playing the note, it's trying to figure out how to do, how would you do vibrato and those kind of things. How do you work with emotion? How do you get that game engine to make something that has an emotive response in the player, right? So that's something that I'm very excited about here, is that you can basically do that abstraction layer in PD, and that would allow us, meaning the creative types, to basically take that and go when they're quickly ramping up the RPM values, then I can actually smooth that, or I'll only smooth it when it goes up or down, or basically you can produce functions that will make your audio engine sound better. And it's sort of you're giving an interface layer between the game and the audio system itself. And I'll go into more details of how I did that in a practical sense when I show the music stuff. All right. So if you want to, there's a website, and they're in open beta, so all you need to do is send them an email and then check it out. Oh, and this whole talk will be on my website as well, videogameaudio.com, so don't feel like you necessarily need to take down notes and stuff. Should have said that at the beginning. All right, so here we go. Okay, so how are we for time? Oh, we're good. So we're 35 minutes in, right? Is that what that means? Okay, perfect. All right, so yeah, first thing as far as a demo, because PowerPoints are ostensibly boring, is that I want to go through my patch here. So I do have a video online that describes part of the patch, but yeah, with this presentation I want to go into a little bit more detail because, there's lots to learn. So, alright, so hopefully it works. Oh, and I have a little visualizer here, but that only works on the PC because there's some funky functions that I was using there, so doesn't, we'll just hide that for now. Okay, great. All right. So I guess I could change the. Is the resolution okay for people? Sorry, I know it's sort of small. I'm not used to working with such a nice projector, so it's actually got great resolution on it. So yeah, I think it's good to just sort of take a step back and then think of like why. Like, why would I do this? The game was meant for high school students, and it's to learn about the cell, and I wanted, like, quite literally, the music to kind of, like, come alive. So I wanted to create a system that really supports that, like, that it could sort of do different things at any given moment. Like I said, unfortunately, we didn't have enough processor and to support this. So what happened with the game eventually is that I flattened it out. I just basically recorded a whole bunch of renderings of this. But this particular patch could generate all sorts of music continuously. So the idea is that it's constrained, but then it also is quite general. So figuring out where that line is really an area that I like dealing with as a sort of an electronic music artist. Right. So, and I think another thing that's important too is that a lot of these components here are actually used, they're borrowed from Martin Brinkman. So I think that when one has an idea, you don't necessarily have to think you don't have to do it from scratch. A lot of these are repurposed, and then it's almost trickier to try and take someone else's work and then understand it and then extend it, right? So I found that was definitely the case. Like, say with the granulation, what I wanted it to do is that I think it's got 12 voices at any given moment, and what I wanted it to do is to basically be able to do a granular crossfade. So when I transitioned from one set of samples to another set, I wanted half of them to be from the old one and half from the new one. So you can hear how the lead line came in there, right? So that's from the sequencer, I can't reach, but the one at the top there, it says mix sequence, or SEQ. And as that pointer moves along there, it basically was changing the mix here. So fairly simple, where it's just bringing in layers, and then what I'm doing here is that I'm just sort of sitting there, it turns off, is that I'm just randomly looking at the position, and then I allow the lead line to come in periodically, and I just did that until I like the sound of it. It's not very academic, but a lot of the times I think that's what it comes down to. As far as the breakdown of how this works, I've got sort of 4 different instruments here. These 3 here are all sine waves. This one here is an FM channel. And then I've got granulation happening here. There's the sample. And then I also have comb filtering here to tune the sound of the granulation, and then I've got reverb and delay here, tempo-based delay. So if I wanted to, the neat thing about generating stuff live is that you can just change the BPM, and you can't do that with samples, it just doesn't work, right? And that's something that's happening even with Wise, is that they're allowing, finally, you can actually put MIDI stuff in there now. So, the thing that's different about this is that the notes are being generated, randomly. So, the way that this sequencer works is that it works, there's 16 steps this way. These are the MIDI note values as they go up there. And so if you put a little toggle there, then that means MIDI note number 39, and then here, 72. So anytime that it selects here, then it'll play those two pitches together, okay? And the way that it moves through the notes is that it's just like, it just does a randomization for all of those 16 steps and then just fills it. So it allows for repetition, you know, like it could replay things. But the thing that I found that was the hack is that to make it sound more musical, rather than having it randomize all the time, I would only randomize every 4 measures. It's really simple, but for me it really works. Because the way that I made all of the bits and pieces here is that they transition like smoothly. Like even the tempo delay here, like if you heard it going down, you heard that like it sounds like it was being bent. Well, that's because I made the tempo delay a variable delay line. So I was stretching out the delay, same as if you know Roland space echo, right? So I wouldn't just cut the delay and then like pop, you know. I actually like stretched it out and like spent some time getting it to sound good. So that when I'm changing my tempo, it doesn't just jump, it actually, you know, it sounds like the way I want it to sound. So if we scroll it up here, you know, you'll probably be able to hear a little bit of the pitch bend happening there, and then it sort of eventually catches up to itself. So it makes it so it sounds like a little bit out of key, but I kind of like that as a transition. It gives you feel like, oh, there's something that's happened here, right? All right, so this is sort of the exploration music. And here I'm using the granulated sound of a motorbike pass by to generate my pitches. So if you want to hear what that sounds like, I might have to make it a little louder, but if I take away, so this is instrument 1, there's instrument 4, this is instrument 2, and then I had instrument 3 that was pan, and then this is the granulation. I'll just put that up a bit. And the neat thing about the granulation is that I'm actually sequencing it as well. So there's like the sequencer at the top, but then there's this grain sequence, right? And so what I did there is, and this was from, you know, like the original patch that Martin had put together, but the thing that happens there is that I'm basically, every time there's a bang, that little pointer thing goes past, that bang, bang, you know, waiting, bang, is that it's changing down here. It's a little hard to see, but what it's doing is it's stepping through different patch changes. So what I'm trying to get at there is that the changes are intentional. So I wanted to make it so that it actually moves through those different sort of pitch classes and stuff like within that are, I shouldn't say pitch classes, it goes through the different timbral material here in this sound. But because I'm also feeding it through here, then I've got intervals that I'm working with. So they're very simple. See, this is G and C, right? This is the 5th. So it ends up being very consonant. But these, because this is coming from a noise-based waveform, and then feeding it through a comb filter makes it sound very, you know, it's like pitched material now. So that's sort of what's going on there. All right, and let's see if we get these guys to change. I don't think so. I think I'd have to go to a different scene. All right. Yeah. All right. So what I'll do is, so that's the granulation layer, and if I get rid of the comb filtering, I think the comb filter is this one here. And so if I take that away, this is what it sounds like. See, I'm almost going to hit that other patch change there at the top. It's a little quiet, but anyways, it's a motorcycle pass by, okay? And if I do a big change here, if I change to the violin sample, all right? So, and now I brought in all those, you know, layers again, because I had a patch change. So you can see here that the pitch, they're really constrained. So here I'm sort of working with like the nice half step there, right? So this is when you're getting attacked by a virus. So it's supposed to be sort of the fight music for the game, right? So it's supposed to be stressful. And then we could go to sort of where things get resolved. Okay. This was I just had like a recording of a synthesizer. So you can hear how it blends the violin granulation with this new sort of synthesized layer. So that's where I'm doing a granular crossfade. So what happens is that if I've got my 12 voices, and they're all, say, at the beginning they might have been all violin. Well, when I transition to a new sample for granulating, then what will happen is that as soon as this guy's done, then I switch that one out and put the new one in, and then when the new grains appear, then eventually it sort of stitches in the new samples, and now I'm playing both of them at the same time. So granular crossfading is kind of it produces a different effect than just simply like volume crossfading. All right. And if I wanted to, the way that I fast forward is I basically put the tempo down to 0 here, and that'll scream through. You watch this guy burn through here. All right. Let's go back to here. So now we go back to the exploration music. If I click twice on it, right? You hear how those grains are finishing up? And now we're back to where we were before. So the thing I really liked about, or the thing that I really worked for, and that I like the result of, is that the transitions are smooth-ish. I worked a long time on that. And then the thing with this patch is that the real trick is that a lot of it is reverb. So if I take away the reverb, it sounds like this. Right? And if I wanted it to swing, I could go like this. Make it funky. Alright. And add the reverb back in because it just sounds so great. So, see? And that's with no direct signal. And then with the direct signal again. Stuff. So if you look here, and that's not all me. So yeah, like a lot of this stuff is reused. But then see, this is my initial here. So I did like some high pass filtering because I didn't like the DC. It's a lot of low end rumble and print. So I just high passed it, and then I also even low passed it in this part. That's pretty harsh. It's a very gradual roll-off. And if we go into this object here, this is sort of more where I changed things. So here I just made it so that it was dynamically allowing you to assign the grain sources for each one of the inlets. All right. So there's one sample. So you can actually look at the sample data. And I didn't even basically normalize the sample data. So I did that in the patch. I actually have like a compressor in the patch. It brings everything down to the same levels. All right. Okay. So what I'll do is I'll show a little bit of the sound effects, and then we can do our Q&A chunk. That should work. All right. So I wanted to. And obviously you could modulate those a little bit nicer, but there's that. And then the sound effects, which this one here, this is more stuff that I did from scratch. This one nice here. Let's go. Font. I think it needs to be a bit bigger. Yeah, that's more legible. Okay, so all of the sound effects are also done, using synthesis. This one I used kind of like a 303 synth, and that's for the user interface sounds. The rest of it is kind of what I like to call idiomatic PD synthesis. So in other words, I used basic PD synthesis functions that I knew would work, like using libpd. So I used the strengths of the language to basically do sort of, in a sense, like some of the easy stuff that I know would sound fairly good. So it has, to me, it has like a PD sound about it. So yeah, what to show first? Well, I mean, I can just play some stuff here. So let's see here. Turn on DSP. Yeah. So here's an alert sound. All right. Error sound. Menu slide. There's that. And the great thing is that, like, it's different each time. So it's sort of, I think it makes the sounds kind of come alive. And the intensity is just so that if you've got stuff like collision sounds, sort of like that on the low end. And let's see. Right? And so you wouldn't have that drag, of course, like from the game. You would just simply feed it a value. And the numbers are normalized. They go from 0 to 1.0. Right. And you can hear, like, each time it's slightly different. Right. There's a fire sound. And as far as the way that all this stuff works, you can actually have a look at it. And they're fairly simple. A lot of the times it's just using, like, say, this one is pretty much just a, like using a sine wave, and then I've got a line function, and that's about it. Oh, and I'm also, yeah, so this is like, it's using like FM, like basics, so, because I've got like this coming in here, and I'm multiplying it by the frequency, like the output of this guy here. So that one's a scanning one. Yeah, it's very sort of sine wave soundy. So it's meant to be sort of like a sonar ping kind of idea. It's a firing sound, another firing sound. So really what I did is I just played around in PD until I liked the way that it sounded. So it's really, this one is, most of them are it's like additive synthesis. It's very basic. And with the aesthetic there, I was going for sort of like a classic sci-fi kind of thing, like sort of old, analog sort of synth sort of sound. And then some of these, like some of the collision sounds, what I also did is did a little bit of where I lowered the sample rate so that it would sound like sort of classic video game, arcade game kind of sounds. So, yeah. But, so there. How about if we leave it there? Because then that way we're at an hour. And then that way, if people need to go to class or do work or something, then you can take a break. So, yeah, thanks. Yes.
It might be really cool. Do you have a short clip of the game so they can see what it
Yeah, of course.
looks like in there?
Yeah, exactly.
It sounds real nice.
Yeah. So here's the game. I think might be this one or it might be this one. I'm a little nervous. No, it's not that one. It's this one.
Ectoplasmic reticulum. Hopefully that gives a better idea of the actual game. Sorry. Sometimes I skip through that because I've seen it a couple times. So, yeah. Any other questions about the music? Sound? Yeah.
I'm curious on the K through 12 side, how's the rollout? How's it been going as a teaching tool and combining visuals and audio with science?
Yeah, it's going really well. So for Strange Loop, basically they have been asked back to do more games. So as far as I know, Amplify is a pretty big company. I think they're they've basically got pretty deep pockets, and I think what they were able to do was to get access to the LA school district. So I think that they've got some, some inroads there. I actually haven't followed up on it, so I'm not exactly sure where it's being used right now. But Strange Loop is, they're continuing to develop educational titles I believe with Amplify as well. So I think, it did well. And it's primarily for high school students. So,
When you present the audio while you're working on pure data to the rest of the team, do you let them play around with the pure data?
No, I didn't actually. The main reason being is that it was, when I was starting it out, yes, I did. So, and part of it was also that it was just, I was working on it very messy. Like that interface that you see here, like that took like 2 days for me to put together because there was all sorts of, it was hard for me to figure out what I wanted to have, what I wanted to look at. And like the reaction from people, it's always funny to say like, oh yeah, and here's like, behind the faceplate kind of things. Like, oh my God. So, but a lot of people look at that interface and they're just like, oh man, it's giving me a headache even from that. So I do have a lot more respect for classic synth design, because like figuring out how to represent the parameters that you want to tweak is tricky. Like that's a real difficult design process, and obviously there's some like synth companies that did it better than others, and because there's so many different parameters that you can change, but you don't necessarily want to have access to all of them at the same time. So that in itself is a difficult thing. And as far as allowing the team to play with stuff, not so much really. None of them really had like a background in it, and
Most of it is just, when working on games, it really comes down to time and money, and so they just didn't have the time to learn, say, PD, then, yeah, it just sort of hit a wall that way. So that's part of the reason why I'm doing talks now, because I'm like, hey, I did this system. No, really, I did. Like, I think it's kind of neat, but the thing is that the win for them was kind of marginal. So, like, say when they, like SimCell 2, they're just like, well, why do we need to have it, live? And I totally understand that, It's just, what I had to do is I had to figure out a system, not so much from this one, but from the other one. You can imagine if I had to manually click on, like, each sound to render it out. I actually put together a spreadsheet where it would just do that automatically. So PD, the way that I'm using it here is real time, so I would just like click and then it would just render out and then, it'd be done in an hour or two basically. And then it would spit out all the files. And I had it so that it could spit out intensities from like 5 intensities, so 0, 0.2, 0.4, 0.6, 0.8, and then 1, right? So that it would give me some variation there on the sample side of it. One thing that did happen on Retro City that was kind of funny is that I exported my sound design and also my music using what's called like tracker-based music. So that's sort of a vertical kind of based music format that has a whole bunch of numbers where you're tweaking like registers and stuff like that. And so the coder, he actually went in there and he made like his own sounds, which was kind of funny, but then also kind of like, yeah, it's like, that doesn't sound exactly, oh, wait a minute, you changed my source code. So sometimes, yeah, it does happen that people have like the interest, so, yeah. Yeah. Any other questions? There must be questions, right? I can also go into, yeah, man.
I've got one that's pretty applicable to kind of us here at CCRMA. So, I mean, building interactive music systems and experimenting with sound in, audio programming languages is one thing, and in an environment like CCRMA where experimental is, encouraged, if not, required, is kind of something we get used to in these environments. And when you transition kind of these kind of workflows and these kind of systems into industry with all the requirements that you laid out, you're shipping something that's solid, that has to perform all the time, it has to come in under budget, all these kind of things. Can you say a few words about kind of the range of people's thoughts on the use of this kind of stuff, on procedural music? And do you find some people are wildly excited and some people could care less and some are antagonistic? There's it's kind of what are some of your experiences that you've run into out there? Yeah, I would the way that I would just sort of bet things will go, and also I don't know if this is necessarily like sort of a core element of being an audio person, but it's kind of like nobody cares. The way I describe it is like even within film, it's kind of like, we're always kind of at the end of it, there's no money left, there's no time left, everybody's stressed out, nobody, and then if something doesn't work, it's all your fault, like it really comes down to, I think, I found that working in audio, and it's sort of a bit of a joke, I'm not totally serious, you do have to be somewhat humble within the process because, I spent so much time like on that stuff and like, yeah, it gets to the end of it, and then the thing is that they're all willing to get somebody to optimize the graphics, but nobody to optimize the audio. It's just like, because it's not, I understand, like, the plus minus just doesn't quite work out. So the way I approach things is really where I'm kind of like, well, if it's going to happen, I kind of need to, in a sense, do it on my own. I give people an idea of sort of what I want to do so that they're not totally freaked out. But say a good example would be like working on, I didn't show it before, but I worked on NBA Jam, which is like a EA, it was sort of a reboot of the arcade game. So that was in 2010. And so we got a whole bunch of music from a composer, well, it was sort of a production team really, and
what happened there was that, you know, us, the audio team, wanted to make the audio, like the whole music, all reacted to the game. So like if you're playing not so well, then the game tempo, music kind of slows down, and the music mirrors the way your performance in the game. And then if you do a big slam, then like, you know, there's like a record grounds like, you know. And so we did this whole sort of scheme using this software that they have there, this proprietary, it's called Pathfinder. So it's sort of similar to like, you know, the adaptive music functionality in Wise and also in FMod Studio, but it's sort of even a little bit more powerful. But what happened was that within EA, that particular piece of software was, what do you call it? It had a weird, okay, basically the person that programmed it wasn't there anymore. So if you've ever, you know, like those, like it basically became a legacy system and nobody wanted to touch it. So as soon as the production team, like the coders on the team heard that we were using that, they were just like, oh, okay, yeah, go ahead. But if anything goes wrong, we're pulling it. Like that's it, it's just gone. Because, you know, you come down to risk and it makes sense, once again. So we did hit a point in which, like this, and it's not totally fair because like the thing is that like every other part of the game is crashing intermittently as well. It's just the way that code works. And so of course, when the Pathfinder stuff was getting to a point where it was like there was a crash that was, oh, well, who are you going to assign it to? Oh, Pathfinder, yeah, it must be crashing there. And it really required the audio coder to just spend like an extra night's work because they're sort of like, oh, we don't really know what's crashing, and then like, oh, we've only got one more day to do this, and oh, it's audio, and like jump, otherwise we're pulling it. And so that's the kind of situation that you get thrown into. And if you don't have that person, then you're just by yourself with the sharks, and you're done. So I would say that that's kind of like, you know, that's kind of like where it ended up on the other side of the fence with SimCell. It's just like, you know, I'm talking about it now, but like it all got flattened to samples, which is okay, but I still would have really loved to have had that interactive in the game. Whereas on NBA Jam, you know, the coder was able to go in there, he was able to fix it enough, and a lot of it is also bureaucratic, so you had to also show that it wasn't doing what the other coders were saying it was doing, and he was just like, no, we're good. And he was basically able to fend them off at the last minute. So, I mean, it does come down to sort of that kind of political stuff too. So, say like when working in like these, when you're working on like multi-million-dollar games and you're proposing a structure like this where you're like, there's just like, okay, well, what kind of music is it going to be? Well, I don't know, it's going to be different each time. And that can freak some people out. So you need to have buy-in, basically. And you need to sort of, so you have to do a lot of like internal marketing to sort of show that, yes, like if things screw up, here's our, you know, whatever fallback position. If things screw up from there, here's our third fallback. So with SimCell, the fallback was to do sampled sound. And so that was fine. And it was totally deliverable, you know, it's worked out great. So yeah, that's kind of, it's kind of like working with, yeah, you need to be able to deliver at the end of the day. And yeah, you can kind of propose stuff. And what we did on NBA Jam is that a lot of it is that because it was a small team for a while, is that we basically got to do what we wanted to do. So we kind of didn't tell people. We're like, hey, you know, we're kind of doing this cool thing. So we would talk amongst each other. And we were almost like an independent studio within EA. And we also had the buy-in from the top, like the producer for the game. He was just like, totally trust you guys, do whatever you want, I'll totally go to bat for you. Awesome. Well, part of the problem is that, so we're working on this thing, and then we get to say like 80% of the way through, and then their main basketball game totally tanks. Like what they had done is that they had taken out the AI, they took out the graphics engine, and they tried to add all new stuff. And then they were trying to compete with 2K, so they were going to rebrand as well. They were going to call it NBA Elite instead of NBA Live. So they were basically doing this big stretch, and then they got to this point where they're like, oh crap, and it totally flopped, and management was like, we're not shipping that basketball game. So marketing was like looking around, oh my god, okay, we need to ship something. So then they looked at our project, our little project, and they were just like, you! And then the full, like, you know, spotlight of like marketing and internal was all on us. And they were just, you know, if we didn't have buy-in from the top, like our producer, then it would have gotten nasty. Because it's one thing to do something creative, it's another thing where they're just like, why are you doing this? Why are you doing this? Why are you doing this? This isn't safe. Or like, you think this is cool? No, it's not cool. It needs to be like this, you know. And then like totally changing the design at the last minute too. But really, it was a whole political thing. Like our producer was able to say like, look, no, we've done something cool. And so those kind of games are awesome to work on. Because a lot of the times you work on stuff and then it's like art by committee. Has everybody been part of that? Like, you know, you have your idea and this is great idea, and then there's like an iteration, like people are like, oh no, that might do this, and you cut that part off, and it's all like this, and then you cut that part off, and then at the end of the day, you just look and you're like, really? Like, it really just doesn't end up at all the way that you're like, yeah, now it's, yeah, it sort of works, but it's like Muzak. It just gets watered down to art as functional. So, yeah, so a bit of a long-winded answer. That's, yeah. Do other people have, questions about like the industry or? Yeah.
Do you think it's a rarity for? Because one of the cool things about you and like the audio that you do is that you do the audio and the music, and both of them are procedural and also intertwined.
Yeah.
Do you think that's a rarity in the game industry as a whole, especially like AAA? Do you see a lot of composers interacting with audio teams or?
Yeah, it is very rare, and yeah, if the thing that's happening more these days is that you do have teams just being smart about that. So say like if you know the game Last of Us, like there's games that there's teams, if they understand that it's like this total work of art, then they really do figure out an amazing balance between sound design and music, you know, and they spend a lot of time in that. So it doesn't necessarily need to be the same person, but I mean, it just naturally happens if you know both sides of the fence. But for the larger games, there's no time. Like somebody just wouldn't have enough time to do all of the music, you know, and all of the sound design for most games. So this is, you know, SimCell was like an educational game, so I was able to do sort of both sides of the fence there. But that kind of stuff is happening a lot more now because people just realize that having, and they're doing it in film too, is where like Randy Tom and other big, you know, sort of Hollywood sound designers are like, look, bring us in earlier on. And then the thing is that we can basically inform the design of the overall film with sound too. You know, like, you know, he's sort of described where most, you know, like the way the films are put together is that there's like a script, right, or a storyboard, and so there's often when he's been brought in for films in the past that there's just no room for big audio events. He's just like, oh, I could kind of shoehorn something in here, but I could, if I had another 10 seconds or something to actually like either build up like audio or ramp down, that would give me space. But if they bring him in super late, the picture's already cut, all that kind of stuff, then he's like, I can't really do that much. So those kind of things are getting better in film too. So to me, that's exciting because I think, yeah, like it's important to see audio being either the sound design, the dialogue, you know, music, ambiances, whatever else it is, as being like supporting the overall design of the art piece itself. And I do believe that games are art. So yeah.
Yeah, I suppose also with film, they're getting less and less screen locked. Because, you know, the editors have these digital tools and they can just like cut 5 seconds. So also, it should be more collaborative by necessity as well from that angle also.
Yeah, and it actually comes back to the previous question too, where a lot of it is just so political because you've got, you know, if you've got a picture editor or a director that's totally fine with you, the sound designer or composer sort of saying like, you know, could you change this a little bit? If they're open to that, that's cool. But so many times you're really like, you're down on the totem pole. Like you're just, you know, if you suggest stuff, then they're just like, what, you think you can direct this? Go ahead, big guy. You know, it's just like, no, I just had an idea, you know. So yeah, sometimes that's more of the problem is that you have a hierarchical structure. And sometimes people are just sort of scared about, whatever, their little area, and they don't really want to be challenged. So those are the kind of projects that can be kind of difficult. It's almost like you have to kind of trick the person that you're giving them what they want, but it's more you're giving them what they need.
Yeah.
Yeah. So yeah, it's fun. I really do like working on productions that are they give you the leeway to do like fun stuff. But yeah, it's not necessarily something that you can plan at the beginning. You just never know, because it really comes down to personalities usually. Yeah. Yeah, any questions about the music or sound stuff or working in games? Does anybody want to work in games? Maybe? Maybe?
A couple of years ago, I was, but then
Yeah.
it's like I just do it as like personal projects now instead of just like talking to people, like you've been saying.
Yeah.
Like it's really hard to do creative stuff that you want to do in the industry. It's usually like what other people tell you to do. So like it's just more fun to do it on your own, and so that's what I so change plans.
Yeah, and I kind of do that in a certain way as well, where my main thing is like education these days, and I really do like doing that. And part of the reason is that I kind of made my own scene, made my own little school where I have and so I have control over what I teach the students and the structure and all that kind of stuff. And because, it can be tricky being within a larger organization and always kind of where I feel like I'm making concessions, where I'm just like, okay, well, I had this idea and I guess I can't try it out here because it's just not cool to do it here. Whereas with my own stuff, I can totally screw up on my own, and then I can say like, I did like the wrong thing there and I won't do that again. But at least you have the opportunity of doing it. So sometimes it's figuring out where that balance is, like where, whatever, you can make money at some other thing, like, I don't know, for me in the past it's been programming, and then I use that to kind of inform, like, oh, well, I can work on cool music projects, but I don't need to make a lot of money at them. So I sort of, I think it's good to look at the sort of total picture that way of figuring out how are you going to survive, like from a financial, functional sense, and then how are you going to survive in the artistic sense? Like how do you still stay like fed artistically? Because the thing is that I know people that get burned out because you get stuck in either a game company or getting stuck like, playing the hits or, like bar band kind of thing or, that to me, I never want to be like that. I want to always like continue to have the possibility of failing hard, in our modern, like, whatever sort of speak. I just want to do stuff that's fun for me, and I don't want to get stuck. And I get really anxious when I feel like I'm getting stuck. So I'm totally fine with people that, are able to do the same thing year after year. That's cool. I'm not there yet. Yeah.
I would really like to work in video games, but it seems like I'm sort of on the side, there's sort of a fork in the road between, there's smaller projects where you're working with a smaller team, you have more freedom, but there's time and budgetary constraints, and then with the AAA company, it's there's sort of this trend towards in-house engines, and then people making in-house graphics for those audio engines, like Rockstar and EA with the Frostbite stuff. But you end up not having that creative input there. You get to work on this large audio project and have that sort of large time scale, but it's tricky. It's not as rewarding.
Yeah, it depends what you want to do. And the thing that I found when I started out like in EA is that, you can still be very creative. And a lot of it is really being lucky enough to work within a team that will support you. Because I've been on teams that have been the opposite, and like quite literally I've been like fired a few times. And I think I'm reasonably okay to get along with. The thing is that I don't really, to speak on my behalf, I don't like to compromise myself, like what I want to accomplish in life. And so when that's diametrically opposite to the people that are managing me, then it can be a problem. So I think that you can learn a lot, and I would really, you know, like working in a large company is cool, but it's good to try and find people that you kind of gel with on a personal level. And it really comes down, it's like a relationship thing, it comes down to trust. It's just like, look, I trust you as like an artist. Whatever you do, you know, you're gonna be the person that lights the fire under yourself, and like, I trust that whatever you come up with will be cool. You know, whereas if you have the opposite side of that, where the person's just like, I don't know, you don't really seem to know what you're doing, and like, this stuff isn't very good, and I don't think that if we gave you more time, you'd get any better, and yeah, I'm actually going to tell a lot of other people the same thing, and I mean, you can try, but like, yeah, your stuff isn't really that good. You know, when you hear that repeatedly in in a larger organization, then you're just like, okay, well, fine. But the thing is that you're like, I've done the same work, say, in those two scenarios, and that's really where it's at. It just comes down to like, you know, politics or bureaucracy or whatever you want to call it. So if you work at a larger company, it's nice to work with people that really support you. So you can, and the neat thing about working at a larger one is that you can just get more money. You know, like I mean, part of the, you know, I had a little tour of the facilities here, and it's kind of nice to have, you know, money, because then you get all the cool toys and tools, and you know, you get to work around other people. Usually it attracts similar people that are really aggressive about, like, you know, nerdiness and intensity about the same thing, and then that's inspiring too. So the thing is that if you work in a smaller company and you're on your own, you can kind of feel a little bit of sort of islanded out, where it's, you know, there's not as much money, you can do whatever you want, but then sometimes nobody cares because nobody actually knows what you do. They're just like, I don't know what you do, but yeah, good luck with that. And then you do it, and they're like, that's cool, I'm kind of busy on my stuff, you know. So yeah, I think both sides are cool, and I like working with both sides of things, either sort of AAA stuff or like with the independent stuff. These days I lean a little bit more towards the independent stuff, but at the same time, if you know, I'm still sniffing around EA, like, because I live in Vancouver, and so the sports games primarily are made up there. And if they come up with some cool tech, you know, especially for adaptive music stuff, then I'm pretty interested in trying that out.
Yeah.
Yeah.
Definitely. And it seems like EA has some motion towards in-house tech work, stuff like that.
They do have pretty amazing tech, like on the audio side of things. They've had some shifts, but you know, historically they have. And so the thing now is that the middleware is really catching up to sort of what their tech is capable of. So it's getting closer, but still some like, you know, at last GDC there was the Rockstar sort of GTA 5 presentation.
That's the talk,
yeah, that Alistair gave, where I was just like, okay, cool. You guys are doing some amazing stuff like at Rockstar North. So yeah, and that's, you know, still, that's sort of like a couple of years away for what's middleware is capable of right now, the publicly available stuff. So that's yet another reason to work within a larger company. But the funny thing is that I heard that the people that were working at Rockstar, like there was like, you know, just say like, there's not that many people that sort of were like, oh yeah, this is an awesome tool. They're like, oh, I'm just doing my sound design here.
Yeah.
Don't really want to have to use all those like, you know, wires and stuff.
Yeah, like they look at like, the SDK they made in-house.
Yeah, so it's funny, like even when you feel like, oh, it must be awesome, like, you know, on the other side of the fence, when you get to the other side of the fence, everybody's just like, you know, it's pretty cool, but, you know, but then there's like one person that's totally going off and like doing all this cool stuff, you know, using that tech, so. Yeah, you never know, it's kind of funny. Yeah, but I'm really looking forward to what happens with Heavy, because I want to basically just feed them a whole bunch of objects and stuff. And the thing is that I've been using like open source for so long that I feel like I want to give back. You know, like I want to sort of basically like clean up that music patch, and then sort of export that out, and then that would allow, because if you can compile everything, and I already did it like in 2001, doing like an audio engine, just a basic one that I could put together sort of my own music system that I could use with my students. And the reason for doing that is that, like, say, Frostbite, and then, you know, like, there's, I can't remember what the tool's called, but Guerrilla Games that they use on Killzone, that it's sort of the node-based stuff as well. that those kind of systems, I can't train people directly in those systems, but if I use pure data, I can kind of like, you know, look at what they're doing, and then I can kind of like, okay, yeah, you know, do something similar to help sort of, yeah, like scale people up to like a job where they would be using one of those systems.
Yeah.
So, yeah.
And that'd be really cool, yeah, with Heavy and like everything being compiled, because then you can prototype really quickly.
Yeah.
Information, so.
Yeah, it's actually like usable.
Yeah,
Yeah.
that's awesome.
Yeah, I think so. Yeah, because it's kind of like, you know, like it's like clay, where you're like working with clay and it's all nice and malleable. And then the way that we, you know, used PD before is that it was kind of like greenware. In other words, you just like let it dry on its own. You're like, oh yeah, but it's kind of brittle. But now you can put it in the kiln and
Yeah,
it's just like, you know, production quality.
They're also coming out with new clay fighter.
Yeah.
Now's the time for clay analogies.
Yeah, exactly. Yeah, I mean, there's lots of stuff happening, and I mean, I'm not going to GDC this year, but I get to hear a lot about it, like in the morning talks and stuff. So yeah, if anybody is interested, like, does anybody follow Game Audio GDC on Twitter? Yeah, because the thing is that like I'm not attending, but I attend like the stuff afterwards, and
Yeah,
you can even do the lunch hours with the Game Audio folk, and they're super nice. So I do recommend it if you're able to do it. Yeah, any other questions? Or we're good? You can also ask me stuff directly too, or like, you know, obviously like, send me an email, here's my email address, or, I mean, we'll be here for maybe a half an hour or so, yeah, hang out for a bit, so we can leave it at that then. Yeah. Okay, cool, thanks.
Thanks,